Let's learn how to find enthalpy change for a reaction using Hess's law and given thermochemical equations. Enthalpy change tells us how much energy is released or absorbed in a chemical reaction. First, let's identify what we're trying to find and what information we have. Our target reaction is what we need to find the enthalpy change for. Carbon disulfide plus 2 water molecules produces carbon dioxide plus 2 hydrogen sulfide molecules. We need to find delta H for this reaction. We're given two reactions with known enthalpy changes. Equation 1, hydrogen sulfide plus oxygen produces water plus sulfur dioxide with an enthalpy change of negative 563 kilojoules per mole. Equation 2, carbon disulfide plus oxygen produces carbon dioxide plus sulfur dioxide with an enthalpy change of negative 1075 kilojoules per mole. Hess's law is the key principle we'll use to solve this problem. Hess's law states that the total enthalpy change for a reaction is the same regardless of the pathway taken. Whether we go directly from reactants to products or take an indirect pathway through intermediate steps, the total enthalpy change is the same. This means we can mathematically manipulate our given equations by adding, subtracting, or reversing them. Let's develop our strategy for manipulating the given equations. First, examine what substances we need as reactants and products in our target equation. We need CS2 and H2O as reactants, and CO2 and H2S as products. Next, decide if we need to reverse any equations to get substances on the correct side. Remember, when you reverse an equation, you must change the sign of delta H. Then determine if we need to multiply any equations to get the correct coefficients. When you multiply an equation by a number, you must multiply delta H by that same factor. Let's analyze our first equation and see how we need to modify it. Equation 1 has H2S on the left side. But in our target equation, H2S needs to be on the right side as a product. So we need to reverse this equation. After reversing, water plus sulfur dioxide produces hydrogen sulfide plus oxygen, and the enthalpy change becomes positive 563 kilojoules per mole. We also need two H2S molecules in our target, so we multiply the entire equation by 2. This gives us 2 water plus 2 sulfur dioxide produces 2 hydrogen sulfide plus 3 oxygen, and we multiply delta H by 2, giving us positive 1,126 kilojoules per mole. Now let's look at the second equation. Equation 2 has CS2 as a reactant and CO2 as a product. The good news is CS2 and CO2 are already on the correct sides of the equation. So we can use this equation exactly as it is, with no changes needed. The enthalpy change remains negative 1,075 kilojoules per mole. Now we're ready to add our modified equations together. First, our modified equation 1. 2 water plus 2 sulfur dioxide produces 2 hydrogen sulfide plus 3 oxygen. Delta H equals positive 1,126 kilojoules per mole. Plus equation 2, unchanged. CS2 plus 3 oxygen produces CO2 plus 2 sulfur dioxide. Delta H equals negative 1,075 kilojoules per mole. We add both equations together, combining all reactants on the left and all products on the right. Now we need to cancel terms that appear on both sides. Look for any substances that appear on both the reactant and product sides. We can see that 2SO2 and 3O2 appear on both sides, so they cancel out. After canceling these common terms from both sides of the equation, we get CS2 plus 2 water produces CO2 plus 2 hydrogen sulfide. This is exactly our target reaction. We've successfully combined the equations. Finally, let's calculate the enthalpy change for our target reaction. We add the enthalpy changes from both modified equations. Delta H for the target equals delta H1 plus delta H2. That's positive 1126 plus negative 1075, which equals positive 51 kilojoules per mole. Our final answer is delta H equals positive 51 kilojoules per mole. Let's summarize the step-by-step process we used. Step 1. Identify your target reaction and the given equations. Step 2. Determine which equations need to be reversed to get substances on the correct sides. Step 3. Determine if any equations need to be multiplied to match coefficients. Step 4. Reverse equations as needed, remembering to change the sign of delta H. Step 5. Multiply equations as needed, multiplying delta H by the same factor. Step 6. Add all modified equations together. Step 7. Cancel any terms that appear on both sides of the equation. Step 8. Add the enthalpy changes algebraically to get your final answer.